Welcome to this video. I will continue to go over compression and stretch, horizontal compression, horizontal stretch, vertical compression, vertical stretch in this video. So please make sure that you have watched the previous video where I discussed about translations, horizontal vertical translation, and horizontal and vertical reflection. So let's get started. First, again, we'll have this orange colored graph of y equals 2 to the power of x. So in order for me to show you guys compression and stretch, horizontal and vertical compression and stretch, I'm going to use 2 points, okay, rather than 1 point. So I'll have 2 points. So 2 points on this y is equal to 2 to the power of x graph. The first one would be, one of them would be 1, 2. And there's another one, that'll be 2, 4. These points are, if you're wondering how I got these two points, I simply just picked some x values. In this case, x equals to 1, x equals to 2, and I substitute them into the equation, y equals to 2x, and my y value would be 2 and 4 respectively. Alright, so I'm just using the equation, substituting the x values in there to get my y coordinates. Alright, so now let's talk about transformation then. If I have y is equal to 2 to the power of 2x, okay, y is equal to 2 to the power of 2x. If I show the graph, if I show this graph, where do we expect this point 1, 2 and the point 2, 4 to appear after this 2 to the power of 2x, that 2 multiplying the x, that transformation? What would that be? Please pause the video, take out your notes, and take a good guess on where are the new coordinates of these 2 points will be. Alright, welcome back. So by multiplying 2 to the x, we have a horizontal compression. Remember, we in chapter 1 we mentioned that whatever we do to the x, it is sort of always gonna be counterintuitive, right? So if I add a 3 to the x, we would assume that it's gonna move to the right, but it actually moved to the left. If I minus 5 from the x, then I would assume that it's gonna move to the right, but I would assume that it moves to the left, but it's actually going to go to the right. So it's always kind of the opposite when we mess around with the x. So here, it looks like we're multiplying the x by 2. So we have a horizontal stretch or horizontal compression. So again, counterintuitively, I'm not going to multiply the x coordinates by 2. In fact, I'm going to divide all of the x coordinates by 2. Right? I will divide them by 2 or multiply by half, another way of saying that. So this point 1, 2 would now be at 1 over 2, and the y doesn't change. Okay, oops. And then this point 2, 4, again, the y doesn't change, so I can put the 4 in there first. And the x will change. The x is gonna 2 multiplied by half will give me 1. Alright, so when I show my graph for y is equal to 2 to the power of 2x, the graph should pass through those 2 points. Okay, it should pass through 1 and 4, and also 0.52. Let's see if that's true. And it is true. So we did it. Okay, so we have a horizontal compression where we divide, we keep all the y values, the y value stays the same, but the x values, we kind of carry out the opposite of what we're multiplying the x with. Okay, cool. Now let's say if I want to have horizontal stretch, so by multiplying the two will give me a horizontal compression. If I want a horizontal stretch, what should I multiply the x with? I hope your answer is something like a fraction, maybe. So 2 to the power of half x. Hopefully that will give us a horizontal stretch. And if that's true, then the point 12, it is now, the point 12 was from the original y is equal to x graph. That will be the y will stay the same, but the x is now going to be multiplied by 2, right? And I will have the point 12 has now become 22, and the point 24 will now become 44. And let's see if they will pass through my line. When I show my line, if it's going to pass through these 2 points. And it does. So in this case, I have a horizontal stretch. Okay. Please feel free to pause the video and rewind this section of the video. It is very important, and when we talk about horizontal stretch or compression, it could be a little bit complicated, so please feel free to rewind if you need to. Alright, now horizontal stretch and compression. Already finished that, so I'm going to remove a few lines. Now let's talk about vertical stretch and compression. So as you can see here, I already have an equation. Y is equal to 3 multiply 2 to the power of x. So it's just 3 multiply the original equation, the original orange equation, right? So in this case, I'm not multiplying the 3 to the x only. In fact, I'm multiplying the original equation to the power of x by the 3. And please pause the video, think about what type of transformation this is. Okay, welcome back. I hope your answer is vertical stretch. The answer should be vertical stretch, okay? In other words, this is a vertical transformation. All of my x values stay the same, but my y coordinates will be different. So this point 1, 2, the 1 is going to stay the same, so I'm going to put it down there. But my 2 is now going to be multiplied by 3. My 2 will be multiplied by the 3 here. Right, so my y coordinate is now at 6. Okay, it's right there. And as for this 2, 4, the x is going to stay the same. And my y coordinate is going to be multiplied by 3 as well. So 4 times 3 gives us 12. And let me zoom out so that we can see the point. There you go. Okay, so we have this 2 points, 1, 2, because this is a vertical transformation, the x stays the same, and the y is multiplied by 3 because of the 3 that we're multiplying here. Same thing with 2, 4, we multiply, the x coordinate stays the same, but the y coordinate, we multiply 4 by 3, it gives us 12. So if we carry out the points, carry out the transformations on the points correctly, when I show the graph, I hope it's going to pass through those 2 points. And it does. So this is a vertical stretch. Okay, this is a vertical stretch. A vertical compression would be changing this 3. Instead of a 3, I would change it to a fraction. So maybe something like, let me hide these points first. So maybe something like, let's go with 1/2. So I have 1/2 multiply 2 to the power of x. And that right now, this is the black color graph that we have. So this point, original point 1, 2, this one right here. Now, again, this is a vertical transformation. So my x stays the same. So now, if I want to find this point, this point right here, what's this coordinate going to be? All I have to do is to keep the 1, but to multiply the y coordinate, which was 2, multiply that by the half that we have over here. Right? The half that we have over here. And that will give me 1. Okay, see that? And then for this point 2, 4, now that point will be at 2 and 2. Okay, so as you can see, the graph just became shorter, so to speak. It's vertically compressed because of this half in front. Okay. Alright, this is the end of the video. I hope you guys find this video helpful. Please make sure you know how to carry out the transformations by now. It is really essential that we know how to do them correctly. Alright, good luck, and I'll see you guys. Bye bye.